Okay, so let's run this, and we see that the high side in this condition, the connection losses is 1.74, and the total losses is 2.4 watts. Now let's use the same condition here. So let's run with this condition. And let's see if everything is matching. So delete this trace, high side, low side, and diode here. Okay, so the diode, let me pick a wider range. Maybe here we are still in the yes, we are still in the transient. So let me check the output voltage. How it is good, the output voltage. It is fairly good. So let's reduce this guy a bit, 66, and let's increase the transient a little bit. We have to make sure that we aren't in the transient, so we can calculate this. Okay, so now we are, the transient has ended. And let's take this interval here. Okay, so this should be good. So the high side has 0.5. So let me write it here. High side equal to 0.5 watts plus the diode, and the diode has 50, so 0.5 watts. And the current should be around sorry, the current is not around 10 amps, and but we said that the output voltage was around 40 volts. Okay. Wait a minute. So I have to insert the duty cycle here, which is 0.5. Okay. My duty cycle was wrong. Sorry for that. Let's wait again. Now the voltage should be around 40 volts, and the current drained should be around the 10 amps. Okay, I think that it is enough. Yes, it is around 40 volts, so it is correct. And now we can calculate the real losses of this circuit. So high side, low side, high side, and diode. Okay, so for the low side we have 1.87. So low side 1.87 watts. For the high side we have 0.98 plus this, which is 100. So for the high side we have 1 watts. And so let's compare to this. The low side connection losses are 1.74, and here I have 1.87. But the total if we add also the gate losses and the COSS losses, we have the plus the switching losses, we have the 2.7 watts. So this method here is I think that it is the most correct because I don't know, maybe LTSPICE is not considering something, but I think that this is more reliable. And for the high side losses, we have 2.39. We are quite far from the we are quite far, even though the formula are like this. We are quite far. Let me check that if everything is correct. FS is that? Yes, I think that everything is correct, and the output current is 10. Yes. So I don't know. Dot temp equal to 554. Let's use the. Yeah, yes, because I didn't put the temperature. My bad. Because when you increase the temperature, the conduction losses will increase. So let's say that this was T equal to 25 degrees. Okay. It is important to also to say that, because now the losses should have been increased. Okay, now let's take again the same intervals, which was more or less around here. So this is the low side. Now you see that the low side has 2.5 watts. And oh, so the total side at 2.7. Now it is correct. It was really strange to see a really big difference. And the high side, now the high side, you see that the high side has really increased. 1.4, and the diode is what? 6 watt. What the hell? 6 watts. The diode. No, it is impossible. You can't have 6 watts of dissipation for the diode. This is impossible. There is something wrong in this. There is something wrong here. It is impossible. You can't possible have. You can't possible have. So it is impossible. You have around which I estimated here 2.4. So now let's use this data for the low side, and let's see how much we have to dissipate. So let's put a current generator here, and let's use this as a power loss, which is 2.5 watts. Now let's use the voltage here, which is the temperature ambient, which is 24, and this is the amp. Now we have to take the resistor. The resistor here is RJ ambient case. Sorry, let me check on the datasheet. Okay, we have junction case, junction board, and junction ambient. So junction ambient. What is the order? Junction. Then should be junction ambient, junction board, and I think the last is junction case. We have to take the resistor here and put it in there. So junction ambient is 64. Junction board is 2.5. Junction case is 1. I think that we can even if we just want to know in an even simple way. So yeah, we can even neglect this partition here and just put 67. And read the temperature here, because it is the same. At the end of the day, the resistor is so low that you don't even care. So this is the temperature, 129 degrees. Now, of course, this is a temperature in which should make you think to use an heat sinker, and so 122 degrees. It is an exaggeration. You have to use an heat sink required. Okay. I think that I think that for now I made a very long video. Sorry for the for before, for the script before. I don't know why. Maybe there was a problem with the folder, but now everything is good. Thank you for your attention, guys, and see you in the next video.